What is a micro agent?
I've grown so tired of AI tools that generate code that would just never work and meticulously debugging all the problems myself until I realized that this is a solvable problem. So typical AI tools work like this. They generate code, and if it works, that's great, and when it doesn't, that's your problem, and that's where they stop. People have thought like maybe you could make an agent, like AutoGPT, that does work on a loop and tries to debug and fix code itself. The problem is they tend to derail, kind of like a Roomba getting stuck under a table. Problems compound and they just get lost and never recover. But it dawned on me, what about instead of trying to boil the ocean and create an everything AI agent, what if we solved a simpler problem? So I made this thing called a micro agent. It does one unique important thing. It doesn't turn prompts into code. Instead, it first turns prompts into tests, which in my experience, LLMs are quite good at generating a unit test file based on requirements, especially compared to generating.
I don't know. I don't know what he's talking about. I'm still a newbie, so I'm not sure about what he's actually talking about. But I'll get there. I think I need to just go to another video. Why AI agents?
2024 will be the year of AI agents. So, what are AI agents? And to start explaining that, we have to look at the various shifts that we're seeing in the field of generative AI. And the first shift I would like to talk to you about is this move from monolithic models to compound AI systems. So, models on their own are limited by the data they've been trained on. So, that impacts what they know about the world and what sort of tasks they can solve. They are also hard to adapt, so you could tune a model, but it would take an investment in data and in resources. So let's take a concrete example to illustrate this point. I want to plan a vacation for this summer, and I want to know how many vacation days are at my disposal. What I can do is take my query, feed that into a model that can generate a response. I think we can all expect that this answer will be incorrect because the model doesn't know who I am and does not have access to this sensitive information about me. So models on their own could be useful for a number of tasks as we've seen in other videos. So they can help with summarizing documents, they can help me with creating first drafts for emails and different reports I'm trying to do. But the magic gets unlocked when I start building systems around the model and actually take the model and integrate them into the existing processes I have. So if we were to design a system to solve this, I would have to give the model access to the database where my vacation data is stored. So that same query would get fed into the language model. The difference now is the model would be prompted to create a search query. And that would be a search query that can go into the database that I have. So that would go and fetch the information from the database, output an answer, and then that would go back into the model that can generate a sentence to answer. So Maya, you have 10 days left in your vacation database. So the answer that I would get here would be correct. This is an example of a compound AI system, and it recognizes that certain problems are better solved when you apply the principles of system design. So what does that mean? By the term system, you can understand there's multiple components. So systems are inherently modular. I can have a model, I can choose between tuned models, large language models, image generation models, but also I have programmatic components that can come around it. So I can have output verifiers. I can have programs that can take a query and then break it down to increase the chances of the answer being correct. I can combine that with searching databases. I can combine that with different tools. So when we're talking about a system approaches, I can break down what I desire my program to do and pick the right components to be able to solve that. And this is inherently easier to solve for than tuning a model. So that makes this much faster and quicker to adapt. Okay, so the example I used below is an example of a compound AI system. You also might be popular with retrieval augmented generation, which is one of the most popular and commonly used compound AI systems out there. Most RAG systems and the example I used below are defined in a certain way. So if I bring a very different query, let's say I ask about the weather in this example here, it's going to fail because the path that this program has to follow is to always search my vacation policy database. And that that has nothing to do with the weather. So when we say the path to answer a query, we are talking about something called the control logic of a program. So compound AI systems, we said most of them have programmatic control logic. So that was something that I defined myself as the human. Now let's talk about where do agents come in. One other way of controlling the logic of a compound AI system is to put a large language model in charge. And this is only possible because we're seeing tremendous improvements in the capabilities of reasoning of large language models. So large language models, you can feed them complex problems and you can prompt them to break them down and come up with a plan on how to tackle it. Another way to think about it is on one end of the spectrum, I'm telling my system to think fast, act as programmed, don't deviate from the instructions I've given you. And on the other end of the spectrum, you're designing your system to think slow. So create a plan, attack each part of the plan, see where you get stuck, see if you need to readjust the plan. So I might give you a complex question, and if you would just give me the first answer that pops into your head, very likely that answer might be wrong. But you have higher chances of success if you break it down, understand where do you need external help to solve some parts of the problem, and maybe take an afternoon to solve it. And when we put LLMs in charge of the logic, this is when we're talking about an agentic approach. So let's break down the components of LLM agents. The first capability is the ability to reason, which we talked about. So this is putting the model at the core of how problems are being solved.
I wonder, does she mean here this is just the programming part, and then this is more like a LLM approach? The programming part, does it mean that you programmed something like an AI agent yourself, or I wonder. Okay, let's see how
model will be prompted to come up with a plan and to reason about each step of the process along the way. Another capability of agents is the ability to act. And this is done by external programs that are known in the industry as tools. So tools are external pieces of the program, and the model can define when to call them and how to call them in order to best execute the solution to the question they've been asked.
I hope she covers what are there any limitations to AI agents, or what are there any drawbacks? I hope she covers that. Let's see. She seems like she does not. Okay, let's see.
So an example of a tool could be searching the web, searching a database at their disposal. Another example could be a calculator to do some math. This could be a piece of program code that maybe might manipulate a database. This can also be another language model that maybe you're trying to do a translation task and you want a model that can be able to do that. And there's so many other possibilities of what can do there. So these could be APIs, basically any piece of external program you want to give your model access to. Third capability, that is the ability to access memory. And the term memory can mean a couple of things. So we talked about the models thinking through the program, kind of how you think out loud when you're trying to solve through a problem. So those inner logs can be stored and can be useful to retrieve at different points in time. But also this could be the history of conversations that you as a human had when interacting with the agent. And that would allow to make the experience much.
I'm still confused as to what she means that LLMs are slow, thinking through the problem slowly.
More personalized. So the way of configuring AI agents, there's many ways to approach it. One of the most popular ways of going about it is through something called ReAct, which, as you can tell by the name, combines the reasoning and act components of LLM agents.
I've heard of that before.
So let's make this very concrete. What happens when I configure a React agent? You have your user query. That gets fed into a model, so an LLM. The LLM is given a prompt, so the instructions it's given is, don't give me the first answer that pops to you. Think slow. Plan your work. And then try to execute something. Try to act. And when you want to act, you can...
But does it really think slowly? I've seen LLMs working very fast.
Define whether if you want to use external tools to help you come up with the solution. Once you call a tool and you get an answer, maybe it gave you the wrong answer, or it came up with an error, you can observe that. So the LLM would observe the answer, would determine if it does answer the question at hand, or whether it needs to iterate on the plan and tackle it differently, up until I get to a final answer. So let's go back and make this very concrete again. Let's talk about my vacation example. And as you can tell, I'm really excited to go on one. So I want to take the rest of my vacation days. I'm planning to go on to Florida next month. I'm planning on being outdoors a lot. and I'm prone to burning. So I want to know, what is the number of 2-ounce sunscreen bottles that I should bring with me? And this is a complex problem. So there's a number of things to plan. One is, how many vacation days am I planning to take? And maybe that is information the system can retrieve from its memory because I asked that question before. Two is, how many hours do I plan to be in the sun? I said I plan to be in there a lot, so maybe that would mean looking into the weather forecast for next month in Florida and seeing what is the average sun hours that are expected. Three is maybe going to a public health website to understand what is the recommended dosage of sunscreen per hour in the sun. And then four, doing some math to be able to determine how much of that sunscreen fits into 2-ounce bottles. So that's quite complicated, but what's really powerful here is there's so many paths that can be explored in order to solve a problem. So this makes the system quite modular, and I can hit it with much more complex problems. So going back to the concept of compound AI systems. Compound AI systems are here to stay. What we're going to observe this year is that they're going to become more agentic. The way I like to think about it is you have a sliding scale of LLM autonomy. And you would, the person defining the system would examine what trade-offs they want in terms of autonomy in the system. For certain problems, especially problems that are narrow, well-defined, so you don't expect someone to ask about the weather when they need to ask about vacations. So a narrow problem set, you can define a narrow system like this one. It's more efficient to go the programmatic route because every single query will be answered the same way. If I were to apply the agentic approach here, there might be unnecessarily looping and iteration. So for narrow problems, programmatic approach can be more efficient than going the agentic route. But if I expect to have a system accomplish very complex tasks, like say trying to solve GitHub issues independently, and handle a variety of queries, a spectrum of queries. This is where an agentic route could be helpful because it would take you too much effort to configure every single path in the system. And we're still in the early days of agentic systems. We're seeing rapid progress when you combine the effects of system design with agentic behavior. And of course, you'll have a human in the loop in most cases as the accuracy is improving. I hope you found this video very useful, and please subscribe to the channel to learn more. By the agentic approach.
Wow, that's actually a very good explanation. If you have a very narrow kind of like task, the programmatic approach is a bit more better. But if you have a bit of a broader kind of scope, the agent approach is a bit more better because it can integrate so many things. So like it can integrate a lot of tools and be a bit more broader. Okay, this makes a lot of sense. Huh. Huh, 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 huh. Huh, 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 huh. Okay, let's see this.
In this video, I'm going to give you my take on agent frameworks. I'm going to tell you why I think they will fail and what to use instead. If you don't know who I am, my name is Dave Ebbelaar. I'm the founder of Datalumina, and I've been building custom data and AI solutions for the past 5 years. And next to that, I create educational content like this to help you do the same and ultimately start freelancing. So let's dive into this video. So with the rise of large language models, so-called
Let me look at this content.
Agentic workflows and frameworks became really popular. And as a result, we saw a lot of them pop up. So for example, we have AutoGen, we have Crew AI, and also LangChain has a way to build agents, and you have a lot more. And the problem with all of those frameworks is that most of them are probably way too complex for what you're trying to do and not robust enough for what you're trying to do. So let me explain. All of these tools and all of these frameworks are really, most of them are built around the core idea of chaining agents together in a way where they can reason and figure out the next step within some kind of workflow. So here, if you look at the definition by LangChain, the core idea of an agent is to use a language model, so an LLM, to choose a sequence of actions to take in a chain. So a language model is used as a reasoning engine to determine which action to take. Crew AI follows a similar approach, where you can very easily design agents, you can give them tasks, and I believe there's also this allow delegation parameter that you can fill in. So agents have backstories, roles, goals, and depending on the overall system, they can decide the next path to take. And the result of that is really cool and creative in a way that every time you run this, you can get different outcomes, you can get new stories, you can build really cool processes for this. But the problem, what I found, is that most of the processes in the real world right now that you want to automate for a business, for example, does not require that much room for creativity. Actually, mostly it's the other way around. You want to take a process that is very clearly defined, and if it's not defined, you want to define that, and then figure out the sequence of steps, the sequence of actions to automate that workflow. And then whenever you need AI to solve a particular step within that chain of problems, that is where a large language model comes in. So let's take a look at this example. So
that's actually quite interesting. Just rewind that for a bit.
You want to take a process that is very clearly defined, and if it's not defined, you want to define that, and then figure out the sequence of steps, the sequence of actions to automate that workflow. And then whenever you need AI to solve a particular step within that chain of problems, that is where a large language model comes in. So let's take a look at this example. So I've been building apps using large language models literally since the day GPT 3.5 came out. And in general, if you look at the app flow of all of these applications, it follows this process. You have inputs in the form of your data, your prompts. Then there is a processing layer, which can be one simple processing step, one LLM call, or it could be a chain of events, multiple LLM calls, intermediate function processing steps, external API calls, whatever. There could be a lot of processing, and finally, there's always some sort of output, because when you're using generative AI, these models create something, they create output, and typically you want to store that either in a database, make it available to a front end, in a chat application, or whatever. Input, processing, output. That is how these projects are set up. Now, if you look at the agentic framework flow of how agentic frameworks are trying to solve this problem.
Generative AI app flow.
It looks something like this, and this is a very simplified version, but really what's going on, they take that input and then that processing layer, that is where all of the agent comes in. And typically there is some kind of a manager or orchestrator in between that can interact with all of these agents who all have specific goals, backstories, and tasks. So let's come back to Crew over here. Here you can see initiate the crew. So you have the crew, the agents, and the tasks. So that is what I would refer to as the manager. That is where you would bring everything together. But when we look at all of these agents and the manager as a whole, all of this is typically connected. Well, it doesn't have to be the case. You could also make it sequential, but in general, this is the agent work framework philosophy, where you have a lot of agents working together. So agent 1 might do something, pass it on to agent 2, but then agent 3 might need something from agent 1, etc. And if agent 3 thinks the output is not good enough, we go back to agent 1, and eventually, if everyone agrees, we pass it on to the manager, and then we have the output. So that would result in the flow that you see over here. And AutoGen and building agents with LangChain all follow similar processes. And the problem with that, how I see it, is we are literally collectively all trying to figure out the best way to build applications around language models, large language models. We're trying to figure out the best workflows. We're trying to figure out how to do this at scale, how to manage hallucinations. And all of these tools, they have their own opinionated way of going about it. And don't get me wrong, I don't want to bash these tools. They're great for certain use cases. I just want to point out that I believe for most of the automation use cases for businesses right now, I wouldn't recommend using these tools. Because, like I've said, you're building on top of abstractions that other developers came up with in a new field, which we are all still trying to figure out. And because you're building on top of these extractions, like this, you probably don't know what's going on behind the scenes, because that's really hard to understand if you dive into a new bloated library that you didn't write yourself. So what I recommend instead is keeping things really simple and building these applications up really from the ground, really from first principles. So really consider for your situation, for your application, what is it that you need, and what are the steps required in order to solve this problem. And if we go back to the whiteboard, the way I currently do that, which I will show you an example in a bit, is I view the generative AI app flow not as an agentic problem to solve, but rather I look at it as a data pipeline. Because if you look at the general flow, input, processing, output, it's very similar to a regular ETL pipeline, extract, transform, load. And the cool thing about data pipelines is they have literally been around for years. Ever since we had computers, people have built data pipelines. And there are a lot more solid principles, design patterns, and approaches that we can leverage when we follow a data pipeline flow rather than an agentic workflow. And also, rather than designing your workflow using circular patterns where, for example, agent 3 can jump back to agent 1, to 2, and then back to 1, you ideally, at least how I like to do it, is I design my pipelines using a sequential approach. So following what's known as a directed acyclic graph, or DAG, which is also what tools like Airflow are built on top of, on that design principle. Meaning that data can only flow one way and not go back.
This is a lot of information overload. All these like terms that he's using, ETL, DAG.
And this overall ensures the reliability of your system. Because in my opinion, you should really design your workflows in a way that if the pipeline, if the flow ends up at 3, it should already have processed 1 and 2, the outputs, so that you can always continue with 3. And it's just about how you frame the problem. And that's why the sequential order really helps for that. So you always know it's first this step, then this step, and in between you can add all kinds of logic and validation. But if your business process or automation process, if you can't draw it out like this using simple sequential steps, I recommend you to go back to the whiteboard and try to make it simpler or split it up even further, because almost every process for most business problems that you're trying to solve, they can be broken down like this. And now the cool thing about viewing the problem that you're trying to solve with an LLM as a data pipeline rather than an agentic framework or workflow is that it becomes much simpler to solve this using code without needing any fancy frameworks or tools. So let me quickly show you an example. So I'm going to show you an example in Python, but again, the cool thing is you can do this in any language because it doesn't matter. If you follow the similar steps of getting your data, chaining together steps in a data pipeline, bringing it all together, and then pushing it to whatever kind of output you're pushing it to. It doesn't matter what language you use, and you don't need any framework. So let me show you an example. This is a project template that I'm building out. So it's called Generative AI Project Template. It's pretty complex. There are a lot of moving parts, and we're building this internally for our company, but I'm going to show you the pipeline process in there because that's what we're talking about right now. So we're currently using the example of creating a system that can take an incoming email, then classify it, and then generate a reply. So this could be what you call an agent workflow or a problem that you can solve using a large language model. Now, the cool thing about designing these pipelines and these solutions for these problems is that you can have one step or you could have 100 steps. It doesn't matter. And ideally in your code, you want to build it in such a way that you can easily add steps and remove steps and change steps. Now, a very common design pattern to do this is the chain of responsibility pattern. So I've used that particular pattern. I will show you in a bit what that looks like and give it my own spin to it by including some pipeline elements into it. And now being able to very easily define sequential steps. And then in between, when it's time to call the large language model, we do that. So let's see what's going on over here. We're simulating an incoming ticket here from a ticketing system. So let me zoom in a little bit. So let's assume we're getting in some data and the ticketing system identifies, okay, this is from an email. This is from info@datalumina.com. And it's an email asking for a potential collaboration.
Okay, so where do large language models figure here since he's going to program it? It seems like he's going to program everything himself. I wonder.
Now, the sender here is Datalumina reaching out to me, so that would be a little bit weird, but you get the idea. We're getting some input data here. And throughout this project, we have identified some pipelines. And for this ticketing system, we are going to define at first 2 pipelines, just for example. So we have tickets coming in from email, and we have tickets coming in from Instagram. So how you could then view that is you have your data pipeline and you have another one for Instagram. So this could be email, this could be Instagram. And again, you could infinitely duplicate this to expand your system. So the whole idea with this project really is that everything has a nice and tidy place for it. So we have our pipelines. So let's see at what that then looks like if we come in here and we process the task. So we take that data, we're using Pydantic models, and we call process the tasks. We then call a pipeline registry, which is using a registry design pattern. Again, a design pattern that is solid, that is proven. And what this does is, depending on whether the channel is email or Instagram, we get the right pipeline. So again, through that frame, we have different pipelines, data comes in, system figures out, okay, we need this pipeline. So we can route different requests to the right place. Okay, let's go one step further and look at what a pipeline actually is. So let's consider the email pipeline. The email pipeline is a sequence of steps. First, we have classify email, and then we have generate response. So in this case, we're only using 2 steps. But like I've said, you can make this infinitely complex by simply adding more steps to the system. And this is where the chain of responsibility pattern comes in. So let me come back to the registry. Let's look at the email pipeline and look at the base pipeline. So the base pipeline step is configured with a run function where it loops over all of the steps in the pipeline and then calls the step.process, which processes all of the data. And you can see there is an abstract method in here called process, and it's just used to pass around the data between the different steps. Now, I'm covering this high level. If you want to know more about this, let me know in the comments. You could research these design patterns on your own. Really, the idea is not here to really get in great detail on how this works, but rather show you how simple it can be by combining 2 design patterns and putting that together in a structured way. So follow.
I'm so confused. I'm so confused. I get what he's talking about. I see, but what, like, he did all this code before? Did he use what, like, large language models to put in this code, or did he code it himself, or did I miss maybe something?
Following all of that, let's look at the 2 processes down the data. That is then used in your like text output query of the email. Then you might save that as an intermediate step and then use that in step 2 to, for example,
Let me see if somebody asked a question in the comments. This seems like a good comment. Use an AI agent framework when dealing with complex nonlinear tasks with unpredictable workflows that require dynamic decision making and flexibility. Use traditional pipelines when dealing with linear predictable processes that demand consistency, precise control, and efficiency. Can you please give it? Can you please give a few examples? Uh,
get the right data through or the right context through a RAG system. That is that is how you could use that, for example. So you store any intermediate data, for example, the category in there, is to show you that you probably on the incoming user data, and having
Okay, let me try this. AI agents use cases.
In this video, I will walk you through 5 agentic projects that we've built for our agents as a service clients. For each of those projects, I will also provide you with some key takeaways and, as many people have requested, the costs. So if you're interested in AI agent development or if you think it's a fad, make sure to watch until the end. Let's dive in. Okay, so the first demo is a state-of-the-art Figma to HTML generation agent. It was created for a company that creates newsletters for some of the biggest brands in the world. So basically what this agent does is it creates HTML files directly from Figma design mockups. All you have to do is provide it with the necessary assets, the Figma mockup, and then it proceeds to work. So as you can see here, it uses one special function that is extremely complex and uses a lot of other API calls to OpenAI under the hood, and then it generates this newsletter that looks almost exactly. You would have to adjust it manually. Here you can say to the agent the specific adjustments that need to be done 10 cents plus some additional costs within $1 for the refinements. A key take firm called Mabic that specializes in software development, data, AI, and cloud services. The problem was that the process for generating unit tests was relatively simple, but at the same time extremely time-consuming. And it couldn't be automated with a basic AI automation because obviously each repo is different, it requires different instructions, and again, it requires iteration based on feedback. So here we decided to integrate this agent directly into the same Azure DevOps environment which their developers use daily. As you can see, here we have a board with
everybody's talking about artificial intelligence these days, AI. Machine learning is another hot topic. Are they the same thing or are they different? And if so, what are those differences? And deep learning is another one that comes into play. I actually did a video on these three, artificial intelligence, machine learning, and deep learning, and talk about where they fit. And there were a lot of comments on that, and I read those comments, and I'd like to address some of the most frequently asked questions so that we can clear up some of the myths and misconceptions around this. In addition, something else has happened since that video was recorded, and that is the absolute explosion of this area of generative AI. Things like large language models and chatbots have seemed to be taking over the world. We see them everywhere. Really interesting technology. And then also things like deepfakes. These are all within the realm of AI, but how do they fit within each other? How are they related to each other? We're going to take a look at that in this video and try to explain how all these technologies relate and how we can use them. First off, a little bit of a disclaimer. I'm going to have to simplify some of these concepts in order to not make this video last for a week. So those of you that are really deep experts in the field, apologies in advance. But we're going to try to make this simple, and that will involve some generalizations. First of all, let's start with AI. Artificial intelligence is basically trying to simulate with a computer something that would match or exceed human intelligence. What is intelligence? Well, it could be a lot of different things, but generally we tend to think of it as the ability to learn, to infer, and to reason, things like that. So that's what we're trying to do in the broad field of AI, of artificial intelligence. And if we look at a timeline of AI, it really kind of started back around this time frame. And in those days, it was very premature. Most people have not even heard of it. It basically was a research project. But I can tell you, as an undergrad, which for me was back during these times, we were doing AI work. In fact, we would use programming languages like Lisp or Prolog, and these kinds of things were kind of the predecessors to what became later expert systems. And this was a technology, again, some of these things existed previous, but that's when it really hit kind of a critical mass and became more popularized. So expert systems of the 1980s, maybe in the 90s, and again, we used technologies like this. All of this was something that we did before we ever touched into the next topic I'm going to talk about. And that's the area of machine learning. Machine learning is, as its name implies, the machine is learning. I don't have to program it. I give it lots of information and it observes things. So for instance, if I start doing this, if I give you this and then ask you to predict what's the next thing that's going to be there, well, you might get it, you might not. You have very limited training data to base this on. But if I gave you one of those and then ask you what to predict would happen next, well, you're probably going to say this, and then you're going to say it's this, and then you think you got it all figured out, and then you see one of these, and then all of a sudden I give you one of those and throw you a curveball. So this, in fact, and then maybe it goes on like this. So a machine learning algorithm is really good at looking at patterns and discovering patterns within data. The more training data you can give it, the more confident it can be in predicting. So predictions are one of the things that machine learning is particularly good at. Another thing is spotting outliers like this and saying, oh, that doesn't belong in, it looks different than all the other stuff because the sequence was broken. So that's particularly useful in cybersecurity, the area that I work in, because we're looking for outliers. We're looking for users who are using the system in ways that they shouldn't be or ways that they don't typically do. So this technology, machine learning, is particularly useful for us. And machine learning really came along and became more popularized in this time frame, in the 2010s. And again, back when I was an undergrad writing my dinosaur class, we were doing this kind of stuff. We never once talked about machine learning. It might have existed, but it really hadn't hit the popular mindset yet. But this technology has matured greatly over the last few decades, and now it becomes the basis of a lot we do going forward. The next layer of our Venn diagram involves deep learning. Well, it's deep learning in the sense that with deep learning, we use these things called neural networks. Neural networks are ways that in a computer, we simulate and mimic the way the human brain works, at least to the extent that we understand how the brain works. And it's called deep because we have multiple layers of those neural networks. And the interesting thing about these is they will simulate the way a brain operates, but I don't know if you've noticed, but human brains can be a little bit unpredictable. You put certain things in, you don't always get the very same thing out. And deep learning is the same way. In some cases, we're not actually able to fully understand why we get the results we do because there are so many layers to the neural network, it's a little bit hard to decompose and figure out exactly what's in there. But this has become a very important part and a very important advancement. That also reached some popularity during the 2010s and as something that we use still today as a basis for our next area of AI. The most recent advancements in the field of artificial intelligence all really are in this space, the area of generative AI. Now, I'm going to introduce a term that you may not be familiar with. It's the idea of foundation models. Foundation models is where we get some of these kinds of things. For instance, an example of a foundation model would be a large language model, which is where we take language and we model it. And we make predictions in this technology where if I see certain types of words, then I can sort of predict what the next set of words will be. I'm going to oversimplify here for the sake of simplicity, but think about this as a little bit like the autocomplete. When you start typing something in and then it predicts what your next word will be, except in this case with large language models, they're not predicting the next word, they're predicting the next sentence, the next paragraph, the next entire document. So there's an amazing exponential leap in what these things are able to do. And we call all of these technologies generative because they are generating new content. Some people have actually made the argument that generative AI isn't really generative, that these technologies are really just regurgitating existing information and putting it in different format. Well, let me give you an analogy. If you take music, for instance, then every note has already been invented. So in a sense, every song is just a recombination, some
So
other
basically
permutation
just
of all the notes that already exist.
basically just generating new content. New content, new code, new everything. Okay.
Already,
Dope.
and just putting them in a different order. Well, we don't say new music doesn't exist. People are still composing and creating new songs from the existing information. I'm going to say Gen AI is similar. It's an analogy, so there'll be some imperfections in it, but you get the general idea. Actually, new content can be generated out of these, and there are a lot of different forms that this can take. Other types of models are audio models, video models, and things like that. Well, in fact, these we can use to create deepfakes. And deepfakes are examples where we're able to take, for instance, a person's voice and recreate that, and then have it seem like the person said things they never said. Well, it's really useful in entertainment situations, in parodies and things like that, where someone's losing their voice. Then you could capture their voice, and then they'd be able to type, and you'd be able to hear it in their voice. But there's also a lot of cases where this stuff could be abused. The chatbots, again, come from this space. The deepfakes come from this space. But they're all part of generative AI and all part of these foundation models. And this, again, is the area that has really caused all of us to really pay attention to AI. The possibilities of generating new content, or in some cases summarizing existing content and giving us something that is bite-sized and manageable. This is what has gotten all of the attention. This is where the chatbots and all of these things come in. In the early days, AI's adoption started off pretty slowly. Most people didn't even know it existed, and if they did, it was something that always seemed like it was about 5 to 10 years away.
Okay. This is a very good explanation. So now what I'm wondering is, where do I actually start? Do I start just learning how to code? Do I start just like, I don't know, building AI agents, machine learning, deep learning? I wonder.
Hello, and welcome to Introduction to Generative AI. My name is Dr. Gwendolyn Stripling, and I am the Artificial Intelligence Technical Curriculum Developer here at Google Cloud. In this course, you learn to define generative AI, explain how generative AI works, describe generative AI model types, and describe generative AI applications. Generative AI is a type of artificial intelligence technology that can produce various types of content, including text, imagery, audio, and synthetic data. But what is artificial intelligence? Well, of generative AI. In supervised learning, testing data values, or X, are input into the model. The model outputs a prediction and compares that prediction to the training data used to train the model. If the predicted test data and a large amount of unlabeled data. Illustration. Likes, yarn, and catnip. In the wave of neural networks, we could give the network pictures of cats and dogs and ask, is this a cat? And it would predict a cat. 2. Fur? Yes. Likes, yarn, and catnip. In the wave of neural network of a statistical model, when given a prompt, GenAI uses the model to predict what an expected response might be, and this generates new content.
What can you build using generative AI?
To getting started building generative AI applications, chat, search, and image applications. So we're going to look at, in today's workshop, really what are the gotchas or what are the important parts you want to think about when building these type of applications. And we're going to do that right after this quick introduction. Getting started building generative AI applications, chat, search, and image apps. So I guess the start of this, when I built this and I named this session, I thought I could cover all of these things in about 45 minutes. I made this presentation, and you know what? I just don't think I'm going to get to image applications. And I think it's a discredit to image applications. Maybe you're here only to learn about image applications, and for that, I am truly sorry, but we will cover chat and search applications, and we actually have a session next week where I'm going to talk about functions, but I'm actually going to include the image application side of that. So if you are only here for image applications, I'm very sorry, and you could put your disappointment in the chat. Yes, I very sorry, but this is what we're going to do. We're going to cover these types of applications. I think they go along the series very well. And yeah, I think this is going to be a good session. So let's get started. So this is going to be following along our kind of a bit of a trailer to our generative AI for beginners curriculum. I don't know. Has anyone seen that curriculum? Let me know in the chat. It's a free sort of GitHub curriculum. And you can basically go to this link here, aka.ms.genAIbeginners. I'm trying to get into my chat window, but I can't. And now I've got you stuck. Oh, here we go. Let me go ahead and type that into the chat, aka MS.Gen. Don't talk and type, people. This is dangerous. I hope that's it. Perfect. But yeah, this is completely free. It does at the moment require you to have access to Azure OpenAI, but we actually are translating this using OpenAI as well. So that hopefully by early next year, we'll have that to you. But it also covers some of the good concepts as well, which I think, again, if you're getting started, you want to get a good foundation before you jump into maybe building your production application. Cool. Another thing is, so all these resources I'm sent to you, share with you, will be on this page, this aka.ms/links.genAI. I think Eric is still in the audience. Eric, if you could do me a favor and put that in the chat. Wow. Look at that, everyone. That was quick. Erica's in our background helping me produce this workshop thingy, and she's got the link already there, ready to go. So I appreciate you, Erica. Perfect. So that's going to be where you'll see a couple of things. You're going to see the links to the course I just mentioned. You'll also see a link to a Discord. So we're building out a community of everyone just kind of learning and trying to build out generative AI applications. So you'll see that as well. And then a collection of other resources that you can learn and start building this stuff. But that's enough of the sort of commercial break. Let's get into some of the content. So this is part of a series, last bit. I just did this one last week, and it's talking about the foundation. So if this is your first time looking at generative AI, I do recommend it on this channel going to that, because that's where I kind of covered some of the foundations, prompting, which is super important even for any type of application, and exploring the different type of large language models out there, open source, proprietary, all these options out there. So helping you kind of make the decision, giving you some pointers at least on that. Cool. So building with LLMs, that's what we'll skip. We covered last time. Today we're going to look at 3 application types, but like I said, 2. which is chats, question, which is generally around like question and answering, and I think that's a lot. Chatting or chat applications have brought a lot of focus. Chat, if you've ever, let me know in the chat, and then prompt 4. So the system message allows us to sort of guide the model in a way. You're on your screen here. So the Azure Studio, for anyone that doesn't know, it's more of a sort of graphical interface of both helping kind of deploy the place. I don't know. In my helping and understanding of your use case, and also don't put like info1.txt and info2.pdf, and some direction on what we'd like to see. Then we're going to give it examples of that. So this is from the last session we talked about few shot learning and how many shots are appropriate. In this case, we're going to use 3 examples, which are coming from the code itself. But basically, that is pulling in any type of follow-up question prompts. The GPT-4 Turbo, which I actually personally haven't used. So I'm thinking with these types as a topic when we're talking about search applications, then create embeddings and embed widely different methods like using cosine similarity.
What's going on here?
So here's a silly but useful mental model for this. You have Einstein in your basement. In fact, everyone does. And by Einstein, I really mean the combination of every smart person who ever lived. To the real Einstein and asking him to proofread a high school report proved that's tradition. You send in numbers, and depending on how the parameters are set, all the numbers come out. And then later on, full sentences. In the form of co-pilots or chat windows. It's the Wild West. Just keep in mind that you generally get what you pay for. So with a free model, you may just be getting a smart high school student in your basement rather than Einstein. Image models will generate images. Describe what you want, and an image gets generated for you. The ChatGPT mobile app is a good example of this. Just for fun, I took a photo of this room and...
Okay.
Hey everyone, this is Lucy, and in this video we're going to be asking tech employees what generative AI projects they're building this year. I'm at a tech conference in Sydney, Australia, and I can't wait to hear what people have to say. Let's go. What is your name, your role, and how long have you been working in tech?
So my name is Ben Osborne. I'm a software engineering graduate at Macquarie Group, and I've been working in tech for 5 years now.
Cool. So first question I have for you is, what are your thoughts on Gen AI and how have you been using it?
Ooh, so Gen AI, it definitely makes my life a lot better.
If you don't have a technical background, but you still want to learn the basics of artificial intelligence, stick around because we're distilling Google's 4-hour AI course for beginners into just 10 minutes. I was initially very skeptical because I thought the course would be too conceptual. We're all about practical tips on this channel. And knowing Google, the course might just disappear after 1 hour. But I found the underlying concepts actually made me better at using tools like ChatGPT and Google Bard, and cleared up a bunch of misconceptions I didn't know I had about AI, machine learning, and large language models. So, starting with the broadest possible question, what is artificial intelligence? It turns out, and I'm so embarrassed to admit I didn't know this, AI is an entire field of study, like physics. And machine learning is a subfield of AI, much like how thermodynamics is a subfield of physics. Going down another level, deep learning is a subset of machine learning, and deep learning models can be further broken down into something called discriminative models and generative models. Large language models, LLMs, also fall under deep learning, and right at the intersection between generative and LLMs is the technology that powers the applications we're all familiar with. ChatGPT, and Google Bard. Let me know in the comments if this is news to you as well. Now that we have an understanding of the overall landscape and you see how the different disciplines sit in relation to each other, let's go over the key takeaways you should know for each level. In a nutshell, machine learning is a program that uses input data to train a model. That trained model can then make predictions based on data it has never seen before. For example, if you train a model based on Nike sales data, you can then use that model to predict how well a new shoe from Adidas would sell based on Adidas sales data. Two of the most common types of machine learning models are supervised and unsupervised learning models. The key difference between the two is supervised models use labeled data and unsupervised models use unlabeled data. In this supervised example, we have historical data points that plot the total bill amount at a restaurant against the tip amount. And here the data is labeled. Blue dot equals the order was picked up, and yellow dot equals the order was delivered. Using a supervised learning model, we can now predict how much tip we can expect for the next order given the bill amount and whether it's picked up or delivered. For unsupervised learning models, we look at the raw data and see if it naturally falls into groups. In this example, we plotted the employee tenure at a company against their income. We see this group of employees have a relatively high income to years worked ratio versus this group. We can also see all these are unlabeled data. If they were labeled, we would see male, female, years worked, company function, etc. We can now ask this unsupervised learning model to solve a problem like, if a new employee joins, are they on the fast track or not? If they appear on the left, then yes. If they appear on the right, then no. Pro tip. Another big difference between the two models is that after a supervised learning model makes a prediction, it will compare that prediction to the training data used to train that model. And if there's a difference, it tries to close that gap. Unsupervised learning models do not do this. By the way, this video is not sponsored, but it is supported by those of you who subscribe to my paid productivity newsletter on Google Tips. Link in the description if you want to learn more. Now we have a basic grasp of machine learning. It's a good time to talk about deep learning.
See your channel.
Which is just a type of machine learning that uses something called artificial neural networks. Don't worry, all you have to know for now is that artificial neural networks are inspired by the human brain and it looks something like this. Layers of nodes and neurons. And the more layers there are, the more powerful the model. And because we have these neural networks, we can now do something called semi-supervised learning. Patterns in the training data. Then after they receive some input, for example, a text prompt from us, they generate something new based on the patterns they just learned. Going back to the animal example, the pictures or data points are not labeled learned. There's a super simple way to determine if something is generative AI or not. If the output is a number, a classification, spam, not spam, or a probability, it is not generative AI. It is Gen AI when the output is natural language, text or speech, an image or audio. Basically, generative AI generates new samples that are similar to the data it was trained on. Moving on to different generative AI model types, most of us are familiar with text-to-text models like ChatGPT and Google Bard. Other common model types include text-to-image models like Midjourney, DALL-E, and Stable Diffusion. These can not only generate images, but edit images as well. Text-to-video models, surprise surprise, can generate and edit video footage. Examples include Google's Imagen Video, Cog Video, and the very creatively named Make a Video. Text-to-3D models are used to create game assets, and a little-known example would be OpenAI's Shape-E model. And finally, text-to-task models are trained to perform a specific task. For example, if you type at Gmail, summarize my unread emails, Google Bard will do the same thing. An important distinction is
In this video, I will walk you through 5 agentic projects that we've built for our Agents as a Service clients. For each of those projects, I will also provide you with some key takeaways and, as many people have requested, the costs. So if you're interested in AI agent development or if you think it's a fad, make sure to watch until the end. Let's dive in. Okay, so the first demo is a state-of-the-art Figma to HTML generation agent. It was created for a company that creates
Okay, after watching all those videos, I'm still not 100% sure where exactly to start. Do I start with like generative AI? Do I learn how to code? Or maybe the question is, what would I need to use each application for? Like what exactly am I using generative AI for? What exactly am I? Okay. Okay, I think that's it for now. I think in the next video I'm gonna try and see what's possible, what can I build, and maybe build my first few apps. And see what is possible with this using generative AI. Yeah, for now I think that's it, because there's still AI agents and there's still generative AI, and then the programmatic. There's also obviously the programmatic approach, and yeah, this is all very confusing but exciting at the same time. Yeah, I'll link to maybe some of the more useful videos that I thought that I saw. If you're also in the same boat as me, hopefully, yeah, you'll learn as well throughout this entire process. Anyway, guys, thanks for coming to my YouTube channel. Cheers, bye.